Hello and welcome. In this video, we are going to explore a clustering solution in Infor Coleman machine learning. Clustering is an unsupervised machine learning technique. This means that we aren't training a model based on known outcomes. Clustering algorithms divide a set of data points into groups so that each group has closely related characteristics. Clustering has a lot of practical applications, like market or customer segmentation, recommendation engines, or anomaly detection. Today we will be working with the publicly available mall customers dataset, and we will segment the customers into different clusters so that our marketing team could develop different marketing campaign strategies for each customer set. In the datasets section of Coleman, import the CSV and give it a name. A link can be found in the video notes if you need a copy of the data. When we examine the data, we find 4 variables: gender, age, annual income, and spending score. Coleman has already identified the data types for us. After a save, make a new quest and import the dataset that we just created. You will also notice that the dataset does not have a target variable. There is no truth to which group each customer belongs to, which is what makes this unsupervised learning. We don't need much in the way of data preparation here, as it's a pretty simple dataset. For a more complicated project, the built-in Prepare Data tools will help you structure, reformat, and prepare your data for a machine learning model. For this dataset, we should let the model know which variables are numeric, which are categorical, and then run the one-hot encoding on the gender variable. This will take a few simple edit metadata blocks and an encoding block. Then, select the columns to be used for the model. We will leave out customer ID because it's irrelevant to the customer's category. Now add the algorithm to the quest. We will use k-means, a clustering algorithm that will group the customers. We need to tell the algorithm that there is 5 features, the columns that we have previously selected, and 5 clusters, the number of groups that we're trying to create. After saving and running the quest, we can view its results, which are centroid locations for each cluster. Finishing up the quest using a scoring block will show you which cluster centroid each customer is closest to. Separately, I'm going to save off the results into a Coleman dataset so we can use some scripting capabilities to visualize the results and gain some confidence in our model. This next part is optional, but I would like to visualize the results, so I'm going to move over to custom algorithms for a moment. And while I'm not really writing a custom algorithm, the Jupyter Notebook functionality will allow me to write some code to visualize the results. I've already made this script here, so you don't need to watch me code, but we can take advantage of some of the Python packages contained in the platform. For a full list of packages and their versions, you can always look at the pip install list. This visual was generated using matplotlib and allows us to see the groups of customers that were created. This visual lets us see several distinct color groups, with a little bit of chaos in the middle. It might be worth exploring this algorithm with 4 clusters instead of 5. With this segmentation, real business decisions, such as marketing campaigns, can be applied to each different type of customer. To deploy this model, move back to the quest and check to see that the appropriate activities are selected for the production quest. Deploying a real-time production quest will expose an endpoint accessible using the Ion API gateway. This would allow a new customer to be assigned to one of the existing groups. New customers won't change the model itself, but periodic retraining can be scheduled with an Ion workflow. Once deployed, we can see this endpoint consume new data and make a prediction to which each customer belongs. You can test this endpoint with some sample data and see the predicted value that the model gives you. For a deeper dive on this type of project, consider trying one of the following extensions. Normalize the numeric features, create additional features for your own customer data, change the k-means hyperparameters and the number of clusters, or try comparing results of multiple experiments and determining the best model. Using Infor Coleman AI makes the application of a clustering algorithm an easy task and can inform real business decisions. To learn more about Coleman Applied Machine Learning, see the Coleman documentation or any of our other great resources in the video notes. Thank you for watching.